Today's unit will be on oceans, waves, tides, and currents. So let's get started. The first question I like to start my lesson off with is asking, why does a sailboat move in the ocean? Well, energy from the wind transfers to the boat. Well, in the same way, energy from wind transfers to the ocean surface, creating waves. A wave is defined as a rhythmic movement that carries energy through matter or space. In oceans, waves move through seawater. Now, there are three things that waves are caused by, but one of them is probably the main reason. That main reason is listed first as wind, followed by earthquakes and gravitational force of the moon and the sun. Now, there are a few parts of a wave that you need to be able to identify. They include the crest, the trough, the wave height, and wave length. Now, the crest is the highest point of a wave. The trough is the lowest point of a wave. The wave height represents the vertical distance between the crest and the trough, and the wavelength is the horizontal distance between two crests or two troughs. Now, looking at the image here of a wave, or a set of waves rather, you can see these words indicated in the image. You have wavelength, which represents the distance between crest to crest or trough to trough, respectively. You have the wave height, which represents the distance vertically from crest to trough. And then you have the listing of a crest and the trough, which are the high and low points of a wave, respectively. Now, wave movement. When a wave passes through the ocean, individual water molecules move up and down, but they do not move forward or backward. When a wave breaks against the shore, it happens because the crest outruns the trough and the crest eventually collapses. This is called a breaker. In this case, water does move forward and backward. Now, what determines the size of a wave? Well, there are three parameters. There's the strength of the wind, there is length of time in which the wind blows, and there's the distance over which it actually blows. But you need to understand overall that waves move energy, not water. Now, we're going to look at some images of some very high waves. And it's almost creating a breathtaking view of the ability of this energy to raise water in this up and down motion. Here you have another image depicting a very high wave. Now, since we're going to talk about great waves, or since I've showed you images of large waves, let's talk about something that we should become familiar with when it pertains to waves, and that's something called a tsunami. I equate it to being called a giant wave. Now, tsunamis are caused by underwater earthquakes, landslides, or underwater volcanoes, and they are most commonly found in the Pacific Ocean. Now, moving on, we're going to now talk about tides. Now, the definition of tides refers to the rise and fall in sea level. Tides are actually caused by the gravitational pull of the moon. Now, there is one low tide or high tide cycle that occurs, and they happen in about 12-hour intervals. Now, the tidal range is the difference in ocean level between the high tide and the low tide. And we'll talk about that more as I proceed. Now, let's talk about this gravitational effect of this moon. Now, what the moon does is the moon actually has a relationship with the Earth such that it causes two big bulges of water to form on the Earth's surface, one directly under the moon, and then another on the exact opposite side. As the Earth spins, the bulge actually follows the moon. And so therefore we get a series of different types of tidal effects. One of those effects is something called a spring tide. Now this happens when the Earth, moon, and sun are completely lined up. During this episode, high tides are generally higher and low tides are lower than normal. And during this phase, they show the greatest difference between the high and low tide. Now, to remind you, spring tides occur specifically when the sun, the earth, and the moon are in a straight line. And here's an image depicting that. You have the sun to the left, and each phases of the moon that could represent the different variations of when spring tides actually occur. And speaking of which, when they occur, you notice that they happen twice a month, occurring at the new moon and the full moon. Now, another tide that I'm going to discuss is called a neap tide. And those occur when the earth, moon, and sun form right angles. That's right. During this phase, high tides are lower and low tides are higher than normal. This creates the least difference between high and low tide. To reiterate, the sun, earth, and moon form a right angle during neap tide phase. And here's an image depicting these phases. So here you have the sun located on the left, you have the earth, and then in both the top and bottom position, you notice the various locations of the moon. This illustrates the various orientations on which the neap tides occur. And again, as with the spring tide, of course being at different dates, they occur twice a month. In this case, they occur at the first and third quarter moons. Now, what are currents? Well, currents are large streams of moving water that flow through the ocean. And there are two types that you'll need to walk away being familiar with. They include the surface currents and deep currents. So, let's talk about surface currents, or what causes them rather. Surface currents affect water to a depth of several hundred meters. Now, these surface currents are driven mainly by winds, and they happen to move in somewhat of a circular pattern. Now, why do currents move in a circular pattern, you may ask? Well, we'll talk a little bit about that and how these circular patterns occur when referred to something called the Coriolis effect. Well, the Coriolis effect is the effect of the Earth's rotation on the direction of winds and currents. So then it begs the question, does the Coriolis effect work the same all over the Earth? Well, as is evidenced with my image, you should notice that the Coriolis effect varies by location. When occurring in the northern hemisphere, or the top half of Earth's globe, the circular pattern occurs in a right clockwise direction. This can be noticed when you flush your toilet at home. The direction of the water spins in a clockwise direction. However, if you are located in the southern hemisphere, in a place such as, I don't know, Australia perhaps, you would notice that when you flush your toilet, that the current of water tends to rotate in a left counterclockwise direction. So, again, northern hemisphere, clockwise or to the right, and southern hemisphere to the left, counterclockwise. Now, the surface currents are generally warm or cool the air above them. They influence the climate of the land near the coast. The currents affect climate by moving cold and warm water around the globe. The Gulf Stream is the largest and most powerful surface current in the North Atlantic Ocean. It carries more water than the Mississippi River. Now the question now asks, does the Gulf Stream carry warm water or cold water? Well, let's take a hint and look at where it's located. If you notice, the Gulf Stream is coming from the south. And if you understand how climate works in general, the further south or closer to the equator you are, the warmer the climate tends to be. So as evidenced by this image here, Gulf Stream is indeed a warm current. So the warm waters of the Gulf Stream bring this mild climate even to areas near the Arctic, such as Norway. Now that we know that the Gulf Stream is a warm water current and it originates in the warm waters of the Gulf of Mexico, we should now be able to understand kind of the flow of warm currents and cold currents. Now, currents which flow from waters near the equator towards the poles are warm currents. Currents which carry water from the poles toward the equator are cold currents. Now, the poles that I'm referring to are the North and South Pole, respectively. Now, looking at the image before you, you should notice this relationship that I've mentioned. Notice in areas that are dotted by the red dotted line where the equator is, there are a tendency of arrows to depict warm currents. And these warm currents tend to try to move in an upward direction towards the poles. Looking further, if you notice near the poles regions, especially if you look in the southern part of the map, there is a tendency of the cold currents to head towards the equator. So this creates kind of a cycle process where you have the cold currents from the poles rise and go in the direction towards the equator, where they are warmed, and then upon warming, then they begin to return to areas where it's cold. So it's kind of this mixing pot in a circular pattern, if you will. Now, I must remind you that the direction of this cycle varies by hemisphere. In the north, there is a way that it goes in terms of current, and in the south, that current flips the other way. And again, we mentioned Coriolis effect as the main culprit, and you can always refer to your nearest bathroom to refer to the direction of Coriolis effect in your hemisphere. So that's how that's affected. And again, the Gulf Stream is a warm water current. And if we looked in a region, perhaps in the southern hemisphere, maybe in, I don't know, the East Australian current or the EAC dude, we'd perhaps notice that the current goes in a different direction, although it is warm. So, moving on. El Nino is an abnormal climate event that occurs every 2 to 7 years in the Pacific Ocean. It is an unusual pattern of winds in the western Pacific that pushes a huge amount of water toward the South American coast. This results in unusual weather patterns around the globe. Now, I've covered an extensive amount of information about surface currents, and I'd be remiss if I did not cover deep currents. So let's talk about those and what causes them. Deep currents tend to move water at greater depths, even along the ocean floor. They move much more slowly than surface currents. Another word for them is thermohaline currents, and they are caused by differences in density due to the temperature and salinity variations. Now, temperature you can understand, and you must be reminded that salinity refers to the amount of salt concentration in the ocean. Now, deep currents move and mix water around the world. They carry cold water from the poles to the equator. Notice how they are structured differently here in the map from the surface currents before that we seen before. They're located kind of in the midsection, if you will, more so than right along coastlines. So, moving on. Upwelling describes the upward movement of cold water from the ocean depths to replace warm surface water moved away by winds. They bring up ocean organisms, minerals, and other nutrients from the deep. Without upwelling, surface waters would have very little nutrients. Now, how do we know so much about currents and so forth? Well, it turns out there was a container that broke apart, and ironically, it was carrying thousands of toy ducks. And they were able to actually track the directions in which these ducks were located. So that's how you were able to determine that there were effects that caused the direction of various ducks to go from one place to another. So, interesting fact. Now, moving on to recap and hopefully finalize the presentation, I want to go ahead and make sure that we're on one accord when discussing the causes of waves, currents, and tides, respectively. Now, waves refer to the energy transfer from the wind that causes the up and down motion of water. So you need to understand that wind energy is responsible for waves. Now, looking at currents, currents are actually caused by the wind on the surface, and then deep currents are caused by differences in temperature and density, which were we used earlier with salinity, which refers to salt concentration. Now, lastly, when we're talking about tides, we need to understand that they are affected by the gravitational pull of the moon and can result in both spring and neap tides in various stages of the month, and they govern whether you have high or low tides throughout the day. And this completes our presentation on waves, currents, and tides.